Hey everyone, and welcome back to the channel. Today we're diving into a topic that's really like the backbone of our modern world, direct current, or as most people know it, DC.
That's right. And we're your AI experts here to help you understand not only what DC is, but why it even matters to you.
Yeah, you know, it's interesting. We use electricity every day, but I don't think we often stop and think like what's actually happening, behind the scenes. So let's break it down. What is direct current?
So at its core, direct current is all about the flow of electric charge, but it's in a single direction and it's constant.
Mm-hmm.
You can think of it kind of like a river, right? It's always moving downstream.
Okay, I like that visual.
Yeah, it's a steady, constant flow of electrons from a point of higher potential energy to one that's lower.
Okay, that makes sense.
Yep.
Now, I know there's this other type of current out there, alternating current or AC.
Right.
So how is DC different from AC, which, flows back and forth?
So the key difference really is the direction of the flow.
Okay.
With DC, it's a one-way street, but AC is more like the tides, coming in and going out, constantly changing direction.
So that difference in how the current flows, that has to affect how we actually use each type, right?
Absolutely. And what's really interesting about DC is its constant polarity.
Okay.
So the positive and negative terminals, they always stay the same, unlike with AC where they switch all the time.
Interesting.
And this makes DC super valuable for some specific applications, especially in electronics, where that steady, stable power is essential.
Okay, so you say electronics, are we talking like all electronics? Because that seems like a pretty big category.
Yeah, you're right, it is.
Okay.
And this is where I think understanding a little bit about the history of DC is really helpful to see how we've used it and how those uses have changed over time.
Okay.
So the story of DC really begins back in 1800 with this Italian physicist named Alessandro Volta.
Volta. Wait a minute, that name sounds familiar. Didn't he do something with batteries?
Exactly. Volta's invention of the battery was really the first time we were able to produce that continuous flow of direct current. And it was like this huge breakthrough. It really opened up the possibilities for everything that came after.
That's incredible.
Yeah.
So the battery was the first step towards harnessing DC power. But how did those early scientists figure out, which way the current was flowing? Did they just assume it was positive to negative?
It's funny you should ask that because that's actually a fascinating little side note in the history of electricity. So Andre Marie-Ampere is another brilliant scientist at the time. And yeah, he did assume the current went from positive to negative.
Uh-huh.
And, for quite a while, everyone just kind of went with it.
So we were basing all this understanding on an incorrect assumption.
Yeah. Pretty much. But later on, as we learn more about the structure of atoms, we realize that it's actually the electrons, which have a negative charge, that are moving.
Wow.
And they flow from negative to positive.
So for a time there, we had it completely backwards.
Yeah, we did.
Wow.
Mhm.
Okay. So even with that early mix-up, batteries were just the beginning, right? Yeah. How did we get from powering little gadgets to, lighting up entire cities?
Right. Well, that next step needed another big invention, and that was the dynamo electric generator, which was created in 1832 by a guy named Hippolyte Pixii.
Okay, a dynamo, that sounds familiar. What was so special about it?
So basically, a dynamo takes mechanical energy and turns it into electrical energy.
Mm-hmm.
Now, Pixii's first design actually generated AC.
Oh.
But here's the interesting part. He was advised by Ampere.
Wait a minute, the same guy who had the wrong idea about the direction.
Yep, that's the one.
Okay.
Ampere suggested adding what's called a commutator,
Uh-huh.
and the commutator basically switches the direction of the current every half turn, so it ends up transforming the AC output into DC.
Wow. So the guy who got the direction wrong helped to improve the dynamo. That's pretty amazing.
It really is. It just shows how even mistakes can sometimes, lead to progress in science.
Yeah, that's a good point. So this is how we started producing DC on a larger scale.
Exactly.
And I'm guessing this led to the first power station?
Right. So in the late 1870s and early 1880s, we started seeing these power stations popping up, and they were using DC to power arc lighting, which was the main way they lit up streets back then.
Okay.
Then we have Thomas Edison comes along with his incandescent light bulb, and that makes low voltage DC even more popular for indoor lighting.
Interesting.
And for a while there, it really seemed like DC was going to be the winner in the battle of the currents.
So what happened? Why did AC end up taking over the power grid when DC was doing so well?
Well, that's a great question, and it really takes us into some of the, limitations of DC, especially when we're talking about sending power over long distances. So one of the biggest challenges with DC is transmitting it over long distances.
Okay.
Back in those early days, they hadn't quite figured out how to easily and efficiently change the DC voltage up or down.
So you're saying that to send power like over a long distance, it's better to have a higher voltage. Why is that?
Yeah, exactly. When you have a higher voltage, it actually means less energy is lost during transmission. You can kind of think of it like a water pipe.
Okay.
A wider pipe can carry more water with less resistance, right? And it's kind of similar with electricity.
Okay, I get that. So how does AC fit into all this then?
So right around the late 1800s, engineers came up with transformers. And these transformers can easily and efficiently step AC voltage up or down.
Okay.
So they could increase it for transmission and then lower it again for safe use in homes and businesses.
So AC basically had this huge advantage when it came to sending power over long distances.
Exactly. That ability to change the voltage levels so easily made AC way more practical and much more cost-effective for building these big power grids.
Okay, so it sounds like AC kind of won the current wars because it was just more efficient for long-distance transmission.
Yeah, you could say that.
But you mentioned before that DC didn't just disappear completely. So where does it still fit in?
Well, even though AC might be the workhorse of the power grid, DC is still super important in a lot of other areas. I mean, think about it. Pretty much all electronic devices run on DC power.
Yeah, that's true. Our phones, laptops, TVs, they all use DC. So how does that work then if the power coming into our house is AC?
Well, most electronics have these little circuits inside that convert that AC power from the wall outlet into DC power.
Oh, so there's like a little AC to DC converter hiding in all our gadgets.
Yeah,
Basically.
basic tool. And it's not just our everyday electronics either. DC is essential in cars, telecommunications, systems, industrial processes, the list goes on and on.
Okay, let's dive into some of those applications then.
Sure.
Let's start with cars.
Yep.
We know they have batteries, which are DC, but how does that power actually make the car move?
Well, the battery provides that initial burst of energy to get the engine going, but once the engine's running, then it's the alternator's job to take over.
Okay.
It generates AC power, and then that AC power is converted to DC to charge the battery and power all the electrical systems in the car.
So there's this constant back and forth between AC and DC happening under the hood.
Exactly.
Yeah.
And most car electrical systems run on what we call a 12-volt system. And they chose that voltage because it's a good balance between power and safety, you know, for most vehicles.
So there's a reason they use that specific voltage. It's not just a random number.
Right. You know, choosing the voltage for a system always involves these trade-offs. Lower voltages are safer, but you need thicker wires to carry the same amount of power.
Okay.
Higher voltages, you can use thinner wires, but then they can be more dangerous if you don't handle them properly.
Right, that makes sense. It's about finding the right balance for what you're doing.
Yeah, exactly.
Okay, so what about those giant power lines we see everywhere? I always thought those were all AC.
Yeah, you're right. Most of those high voltage transmission lines are carrying AC.
Okay.
But there's actually a really interesting development.
Okay.
High voltage direct current, or HVDC as it's called, is becoming more and more important for some specific applications.
Wait, so DC is making a comeback in the power grid?
Kind of, yeah.
Why is that? What are the advantages of using HVDC over AC in those cases?
Well, when you're sending power over extremely long distances, especially underwater, HVDC actually has some big advantages.
Okay.
It loses less energy compared to AC, and it can sometimes be more cost-effective for certain projects.
So you're saying for like really, really long distances, DC might actually be the better option. What kind of situations are we talking about here?
Think about transmitting power across oceans, you know, connecting those offshore wind farms to the mainland grid.
Right.
Or even linking different countries' power grids together. Those are all areas where we're seeing more and more use of HVDC.
Wow, I never knew DC played such a big part in all this modern infrastructure.
It does.
And with all this focus now on renewable energy like solar and wind, it seems like DC is just going to become even more important.
Absolutely. I mean, solar panels and wind turbines, they naturally produce DC power.
That's right.
So as we move towards a more sustainable energy future, figuring out how to efficiently integrate those DC sources into the grid is going to be super important.
This is all fascinating. We've gone from the early days of batteries and simple circuits to this complex world of AC and DC powering everything around us.
And a story's still being written, you know? As technology keeps advancing, who knows what new and exciting applications will pop up for both AC and DC.
Yeah, it's really amazing to think about how something as like fundamental as direct current has had such a huge impact on, you know, how far we've come with technology.
It really is. And it's not just about the past either. You know, DC is going to be even more important in the future. Think about electric vehicles. They run completely on DC power.
Oh, yeah, that's true. Electric cars are getting more popular all the time.
Yeah.
So I guess that means as we move away from gas-powered cars, we're going to need a lot more DC charging stations and stuff.
Yeah, exactly. And it's not just cars either, you know? We're seeing electric buses, trucks, even airplanes are starting to be developed.
Wow.
This whole shift towards electric transportation, it's going to change how we produce and distribute DC power in a big way.
So as we wrap up our little exploration of direct current, what are some of the key things you want our viewers to remember?
I think the main thing is to keep in mind that DC is all about that steady one-way flow of electricity. And even though AC kind of took over for a while, DC is definitely not a thing of the past.
Yeah, for sure. From powering our everyday devices to playing a crucial role in big infrastructure projects and, renewable energy systems, DC is working behind the scenes in so many areas of our lives.
And with all the new technologies coming out all the time, the future of DC is looking really bright.
I like that. I think we've all learned a lot about the power of DC today. Thanks for joining us on this journey.
My pleasure.
And to everyone watching, we hope you enjoyed this look at direct current. If you have any questions or thoughts, be sure to leave a comment down below. And if you like this video, please hit that subscribe button and turn on notifications so you don't miss out on future videos where we explore the world of technology. See you next time.